In this demo, we will use GuideMia Ortho Plus software to perform treatment planning and aligner design. The case has patient CT scan, model scan, facial scan and X-ray panoramic picture. A mouse indication software is used to show which mouse button is used. Red, blue and green feedbacks are for left, middle and right buttons. Keyboard presses are shown in the lower part of the screen. First we create a project by loading the patient's CT scan. CT data is now loaded. 3D reconstruction is finished and 2D slices are shown as different views. The mouse movement convention is like this: left button for rotation in 3D windows or thresholding in 2D views, middle button is the pan operation, and right button for zooming. After loading the CT data, first we adjust the threshold some low value in order to create a model for the facial area. We change the region of interest box with the 2D windows, and the thresholds using the sliders. Cut the area to finish the model creation. Then we adjust the thresholds so that bone structures are shown properly. Use circle buttons to select upper jaw and lower jaw in 2 separate steps. As a general guideline, we suggest to CT scan the patient with the jaws slightly open. This demo actually shows a case that is not very well prepared. Now we've finished the basic CT data processing. Now we load the patient optical scan. Upper jaw first. Then define a couple of points on the jaw in order to generate a preliminary arch curve. The points need to be placed in a similar order. We place them on the premolars and central incisors. Next we load the lower jaw scan. Facial scan. In this case, a colored OBJ file is loaded. We use right mouse click to access the context menu, and select the register button to align the facial scan in the patient's CT scan. 3 points are selected in both sides and the aligner button is clicked to register them. One can use any number of points for the registration purpose, but in general 3 points are specified. The points should not be on a line or evenly distributed. Now the facial scan is in place. We can then load clinical pictures. The pictures can be common image format. In this case we load the X-ray Pino and some other pictures. The image viewer can be used to go back and forth to view pictures, and the individual pictures can be added to the 3D scenes to an overlay with 3D models. This can be useful when we want to simulate some visual effects. Both scans have been processed and are closed solid models. Unfortunately, the files have various quality issues, which we will show later. We will perform automatic fixing operations over the scans, but it is desired to have open shells instead of solid models. On the other hand, very often we receive open shells, and want to trim and close them. First we draw a boundary curve of the tooth area. Keep some margin from the teeth. Then use the trim button to finish. The operation all-in-one fix is used to fix typical model problems including small holes, triangle overlapping, self-intersection, sharp areas, topological issues, etc. in just one mouse click. When we want to switch model, we use right mouse click and make the model current. Same tracking and cut operations can be applied to another jaw. And then the all-in-one fix operation. In this case we can see the lower jaw has very obvious problem. The fix operation is applied twice so that we can see the model is well fixed. After such preparation, we can then close the shells and make solid models. The handles are dragged to resize the models. Next we register the models with a patient CT scan. Similar process as facial registration. 3 pair of points are selected. One of the reasons we suggest to scan the patient with jaws open is that it can be easier to specify points for registration. If a registration is not well done, you can always use the reset button to start over. The next jaw button will switch to the lower jaw, and the registration process is the same. At this point all the model processing has been finished. We will then extract and adjust tooth boundaries. The left window is for the lower jaw, and right window the upper jaw. We show the arch curves, generate lower and upper tooth boundaries. In case we need to show and hide objects in the right 3D window, we can use the right-click button and bring up menus. Depending on the details on the optical scan, especially the tissue area, the boundary curve may now follow the actual boundary very well. It is necessary to adjust the boundaries. You can drag anywhere on the curve, use delete key to remove some unnecessary nodes. Make sure the curves well follow tooth boundaries. It is important for tooth segmentation. After all this is done, we can move on with tooth segmentation. Now we go to segmentation page, click the segmentation all teeth button, and wait for all the teeth are segmented. If the boundary is well defined in the last step, the segmentation typically will not need much intervention. The system finished the segmentation now. After we click this Fix All for the jaw button, the system will automatically do post-treatment for the results, including smoothing the boundaries, fixing interproximate areas and adjusting the tooth orientations. If for any reason we don't like the segmentation results, we can delete segmented teeth by right-clicking, and use manual segmentation tools. After the fixing, we further investigate the tooth orientations and adjust them. Use the middle mouse button to select and show orientation widget. Rotate the view so that we can see a tooth from the occlusion side, and then rotate the bounding box to align with the tooth and view orientation. This way we can fix the tooth orientations one by one. After this we can check the FA curves on the buccal side. Then we switch to the lower jaw. Performance segmentation and fixing in the same process. After the tooth segmentation, we want to segment the roots from CT data. Clicking the button to enter the segmentation mode. In this view, we see the axial view, where you can use left mouse button to adjust the thresholds. The assembly view has an area of the CT data surrounding the tooth. We can rotate the view, change thresholds, use the circle button to cut the area until we like the root geometry. The Finish button will then create the model and move to the next tooth. We will need to create the roots one by one. However, the root segmentation is optional for both jaws. We can perform this operation when all crown segmentations from optical scans are finished, or we do this as one step of one jaw. In this case, we will need to switch back to the upper jaw to finish. Once all the roots are segmented, we can move on with initial tooth setup. Turn 1 and adjust the occlusion plane, arch curves, adjust the arch curves width and curveness, or adjust individual handles on the arch curves. The arch curves are supposed to be at the buccal side at this time, meaning the target position of the buccal side of the teeth. We can determine to move the entire curve back or forth depending on how we want the two jaws are articulated. If there is underjet, for example, we can move the upper curve buccally, or the lower curve lingually, depending on how the desired treatment will be. The slide here is used to adjust to what extent we want to do the automatic initial setup. This operation will align teeth according to the curves and tooth orientations, adjust interproximate collisions, etc. Before this step we can actually right-click on a tooth and tell the system not to move the tooth at all. Once the preview is shown and accepted, we can click the Finalize button. A full simulation is then performed. Another round of automatic placement can be done if we decide to adjust the arch curves to further move teeth. After this, teeth can be individually moved. Now click the upper jaw button to start adjustment of the jaw. We check the views and select the tooth we want to move. Placement widget is now shown. We can drag the handles, or direct drag the tooth. If we hide the tissue model, we can see the virtual rotation center of the tooth. According to actual situation, the center can be moved along the axis. If a handle is dragged, the tooth will be rotated about the center. If simply pick the tooth, the rotation is done around the geometry center of the tooth. This is for placement only, not really for stepping plan later. Use the right click to access the context menu here. Turn on occlusion color map. We can see how the jaws are articulated. If moving the teeth at this time, we can notice the changes of the occlusion. The brown and red colors indicate the collisions between the teeth. At any time, this button to adjust IPR will eliminate all the IPRs by adjust tooth positions along the arch curve. Notice that IPR allowances can be set by the user. Now we enter movement step planning. First, we can play back the movements, turn on and off the bone structures and roots, change the opacity of the bone, review the movements from all orientations. If the tissue models are hidden, the playback can be much faster. In the lower part of the window, there is a table indicating the movements of the teeth in each step. The number of microns indicate the maximum point movement on a crown at a given step. As we know, typically it is suggested to be 0.2 mm range. We can insert steps by right-click any step of a tooth. We can then play back the movement. Visually check if there is a need to delay the movements of some teeth, and set a start step of any tooth movements. There are many functions in this page in the context menu. Here we mainly show how a keyframe can be set for a tooth, and the tooth can be moved to different place at that step so that some spaces can be created for neighbor teeth. If we feel like to, we can go back to planning page to adjust the target position of the teeth and come back to plan the movement steps. After the planning is done, we go ahead to Aligner Design page. First, to automatically add attachments or power ridges. The automatic attachment function only allows rectangular attachments now. Users can manually add attachments of many other types, and GuideMia is an open system that allows you to find your own attachment collection. Click the Tag button, change texts, move the Tag tool, and then click the button to finish. In order to print aligner models with a flat platform, an additional step can be taken to add a platform features. After all of this, click Generate button. The system will generate all the files. Another option here is to avoid collisions aggressively during the model generation process. It is sometimes not completely clear to the user if there are collisions in the intermediate steps. This option will help avoid collisions. At the end of the operation, the system will pop out a message with such information. For each step the files are exported in the user-specified folder. The file naming convention will indicate the jaw, the step order, etc. The output files are standard STL files. We can use any software to view them. In this case we MeshLab to view individual steps. In the second try, we design the aligners. All the aligner models are automatically generated and trimmed. They are ready for printing with necessary clearance defined. The MeshLab and GuideMia can both use to review the design results. This concludes our demo.